Thanks for coming. My name is Chris Price, and today I'm going to be talking to you about creating D3 components and a personal roller coaster of emotion, pain, joy, frustration, and enlightenment. So I'm going to quickly run over D3 for those who maybe haven't heard of it, run over the key concept in D3 as I see it, data join. I'm going to chat through how you create components in D3, so that's like the unit of reuse. And then I'm going to chat through our experience. So I suppose before I go through the basics, who here has heard of D3 before? Good. And who's using it? Who's used it? Okay. All right. For those people, bear with me through the first section. But for anyone else, I'll quickly skim through it. So D3 is kind of, I suppose it's a framework that's been around for about 4 or 5 years. It is a bit old school in that regard. It's kind of an all-encompassing framework rather than kind of a, I don't know, micro framework. So I suppose the first thing that's in there is kind of a jQuery-like DOM abstraction. So that gives you stuff like selection. So you've obviously got your DOM tree. And I suppose an important thing is people can assume that D3 is just for SVG. That's how it's commonly used, but it can be used with any DOM. So in this case, we just select arbitrary elements in the DOM by ID, or we can select kind of multiple elements by class name. We've also got manipulation. So there's no point in selecting elements if you can't do something with the element. So you can set the text, attribute, style, height, normal stuff. You've also got abstraction across events. So yeah, I suppose interestingly in D3, events are namespaced, and you're only allowed kind of one handler per namespace. So if you ever get into D3, that can trip you up. Watch out for it. Again, it's an old school framework, so it's got an XHR abstraction. Yeah, there you go. And it's got animation. So again, very similar to jQuery. Take this selection, style the background blue, transition it over the course of 100 milliseconds, that would be quick, in a linear fashion to red. Pretty basic. It's probably what you'd use CSS transforms for, transitions for these days. But where D3 is kind of different to jQuery is D3 has layout algorithms in it. So D3 does a really good job of separating computationally or algorithmically complex components from kind of the rendering side of things. So an example of that is a scale. Now a scale is, I suppose the easiest way to think about it is it's kind of like the axis on a chart. So you have a load of data. That data is in a data domain, as in it might be dates. It might have a scale between 0 and 1,000,000, something like that. And you want to plot it onto a chart, and that chart has a pixel range. So that pixel range is probably something like 0 to, I don't know, 500. So you need something to transform between those two values, and that's kind of what a scale does. So it takes data domain values and converts them into a pixel range value. This is the first time you can kind of see the D3 syntax for creating components as well. Not creating components, kind of consuming components. You create it from a factory method. You configure it. So in this case, we set the data domain to be -10 through 10. And then we give it a pixel range, so 0 through 500. And then we just use it. We invoke it as a function. And we give it -5. So if your maths is good, then you can probably spot that that would give it 125 out. You can also go the other way. So if you're trying to go from a pixel value, so you've got some kind of user input, and you want to get back to a domain value to do something like show a useful tooltip or something like that, you can go the other way with .invert. And the other thing it does is the most complicated part, if anyone's ever built an axis before, is the tick calculations. It seems a really trivial thing, but you're trying to pick some values for your axis such that you get nice pretty labels that don't overlap with each other. If they overlap, you've then got to, because they've got a text label on them, you then have to reduce the count, but then you have to work out what's then a nice number of tick points. So it's quite a complicated thing. So that's all bundled within scale and done for you by D3. So that's really nice. We've got other kind of layout algorithms as well. So We've got more specialist layouts, like if you wanted to make a pie chart, got a layout which does kind of the maths behind that one. Again, kind of simple maths, but there's no point you writing it from scratch. You may as well just use what someone else has wrote. And this is where we get stuff that I haven't really used before, so I'm going to gloss over it. But this is kind of, so it's got geometric primitives in it as well. So again, kind of mathsy heavy stuff. It's got geographic projections. It was actually D3 that taught me that you're allowed to use kind of any UTF-8 character in JavaScript. So yeah, that blew my mind. I don't understand how it works. But what I do understand, because I've done quite a lot of charting, is as well as having the algorithmically complex side of things, you've also got the kind of the rendering side of things. So they are distinct, but D3 doesn't leave you stranded. It does provide something to render it with. So in this case, create a scale, as we did before, but this time kind of introducing the axis. And all you do is you give the scale the axis. No, give the axis the scale, and then tell the axis to render within a container. And it will invoke that tick calculation method, get the ticks back, and render them as an SVG path and SVG text elements. You've also got other useful things like path data generators. So path data generators are, if you've ever used SVG or kind of looked at an SVG, paths have this kind of weird syntax where it's like a string of instructions. It's kind of like logo, if anyone remembers that. And you don't want to be building that up by hand. So it's nice that D3 can kind of do that for you. So I know I just want to plot this data. So here's the list of coordinates. You go away and you give me back the line points that will, the path string that I should use for doing that. Again, nice. It's also got a load of MISC in it. So like date formatting, time formatting, useful stuff if you're doing time-based plotting. Yeah, so that was kind of D3 in a nutshell. There's lots of bits to it. It's a very expansive API, but you get rewarded if you do try and learn it, because I suppose a personal point of frustration is to spend ages making a really nice component which implements some really cool feature to only find out that actually if I'd read down a little bit further in the documentation, there was that exact same component. But yeah, it's a learning. I've had the pain. You don't have to read it. So yeah. Oh, that's annoying. That should be in the middle, but that's like the most basic chart. That's the chart everyone expects to see out of any charting library. Not that D3 necessarily is a charting library, but chart. This is kind of where you get a bit more wacky. So this is using stuff that's all like built into D3. It's a bit different. It's like a force directed graph or force layout with like some collision detection built into it. I could just keep playing with that. So it's got so charts and kind of other stuff you might not expect, and then it's just got kind of crazy shit. So I don't know what this is for. So yeah, D3 in summary. It is a jQuery-esque DOM abstraction. It's got layout algorithms. It does a really good job of separating those out. It's got SVG helpers, and it's got kind of MISC. And hopefully kind of tying us into the next bit, it's got data binding in it. So am I okay to grab a water? Yeah. Okay, so when I say D3 does data binding, I'm basically referring to D3 data join. So I knew about D3 for a long time, and I kind of just thought it was kind of for drawing charts, and it was a bit like jQuery and blah, blah, blah. The thing that it actually took me a long, long time to fully appreciate was data join and kind of what it can do for you. And that's because it's quite impenetrable whenever you read about it. And it's not a concept you kind of find elsewhere. So I'm going to go through it, trying to keep as far away from D3 as I can while still kind of introducing you to the concept of data join. And I'll warn you now, it contains spoilers. So I'm going to explain it with the help of the USS Missouri. Few smirks already. So data join, what we want to do for any data join, or any kind of data binding in a browser is you've got some DOM nodes, and you've got some data, and you want to bash them together and merge them nicely and be in control of that. So we're going to start with an HTML structure. Hopefully everyone's familiar with HTML. We've got a header, we've got a list. The list has 3 items in it, but it's completely unpopulated at the minute. We have the data, which is the other side of it. So the data, we have 3 items. We have Captain Adams, Commander Krill, and Chief Petty Officer Ryback. So we want to do that. Oh, before we get onto the data join, a key part of data join, and I'll keep coming back to it, is it's an idempotent transformation from data to a DOM structure. That's a very wordy way of saying if I run the same code more than once, I will end up with exactly the same DOM structure out if I don't change the data. So to demonstrate that and to try and kind of drive that home, hopefully people are familiar with kind of render loops. Generally, it basically just keeps running and running and running. And in the browser, you do that with request animation frame. So you can imagine that all of the code snippets I'm about to show you are just constantly being run through this kind of request animation frame render loop. So back to data join. First up, we're going to select the DOM nodes. So to select the DOM nodes, hopefully it's recognizable. We select the UL, and then we select all the children of the UL, which are LIs. We then need to do the kind of mashing together bit. So the mashing together bit is as simple as once you select the DOM nodes, associate data with them. So select all data, mash them together. Now, what's that actually done? Well, that's kind of taken the first DOM node, so the first LI, it's taken the first data item and it's associated them. It's taken the second DOM node, it's taken the second data item, it's associated them, third DOM node, third data item, associate them. So that's great, but I mean, like, we haven't rendered anything, hasn't got us anything useful yet. So let's use that association to update the HTML element. So do that, it's quite simple. We're just going to set the text of the LI to be something that we've pulled from the data item. I suppose the key bit here is that because it's associated the item with the DOM node, it's not associated the array with the DOM node. We're not doing anything with indices. It's fixed that for us. So we run it, or it was running all the time in my world. So this is the DOM structure that pops out. It's what we expect. Great. I think that's as far as most people kind of take D3 when they first learn data join. Like that's the extent of it. But actually, it's a bit more subtle than that. So it was all going kind of really, really well on the USS Missouri. Everyone was happy. Chief Petty Officer Ryback was cooking, all that kind of stuff. And then this guy turns up, and he just ruins it for everybody. So not only does it ruin it for them, so we add him as knighted to the data. Stranix, he's also ruined our data join, the bugger. So we've got the 3 items there, but we've got like this 4th data item, and it's not showing up in our DOM. So where's it gone? Well, remember what D3 was doing? D3 was saying first DOM node, first data item, second DOM node, second data item, third DOM node, third data item. I don't have a 4th DOM node, but I do have a 4th data item. Like, how do I handle it? Like, help me out here. And we haven't told it what to do. So all we've got to do is help it out and say, and we do that with the enter selection. So the enter selection is if you ever come across a data item and you don't have a DOM node, whack a DOM node in, whack an LI in. If we run that again, it's always running, it's in a render loop. Then, yeah, Stranix pops out, all good. But yeah, I said it all goes wrong, and it all goes very wrong for Captain Adams. So yeah, he's off. There's now 3 of them left on board, so we've got 3 data items, and we want to see what that's done to the DOM, and we've got a change. Great, it's better than we had before, but it's actually worse than we had before. We've now got two items at the end, so where'd that last item come from? Data item, DOM node, data item, DOM node, data item, DOM node, DOM node, no data item. It's like it's missing. So again, D3 is like, helps out. So we just need to help it out in that case. We do that with an exit selection. And the exit selection is just remove the DOM node. All good. And there we go. It's fixed. So yeah, if you haven't seen Under Siege, in the end, Ryback wins, and now all works, so it's fine. Yeah, so data join is an idempotent transformation of data into nodes. The idempotent bit's important. Kind of come back to that. Live coding. So I kind of want you guys to be able to leave, and if you haven't played with D3, or even if you have, kind of be able to create a D3 component from scratch after this. So I'm going to attempt to do one in front of you, because eat my own dog food and all that. So I've got kind of like some boilerplate here, and what I'm going to do is extend this boilerplate to draw a bar chart. That would be cool. So bar chart, from your perspective, bars are going to grow in from the left, and they're going to grow to the right, depending on their data value. The height is going to be fixed, and it's going to depend on how many bars we've got. So pretty straightforward. To start with, data join's the center of the universe, so we'll start with data join. So we select all. I was going to type li. We're doing rectangles this time. We're in an SVG. We're drawing bars, so rectangles. Data, mash them together. And we know from a bit of previous experience that it isn't worth crap without an enter selection. So enter.append rect. And then also you need an exit selection. So exit dot remove. Cool. Skip that bit for now. We also need to put an action in once we've got our rectangles. So with our rectangles, we're going to set some attributes. So the interesting attributes are, it should start from the left. So that's constant, 0. That's easy. We want it to grow from the left to the right. So we want the width to depend on the data value. So that's quite easy. So function. So the data value is bound to that node. We could do the calculation ourselves to kind of transform between the pixel values and the data domain values, but we learned we can kind of use X scales for doing that. So if we do that, and there we do. So to fill in an X scale is just a D3 scale linear. And it has a range, and the range is the pixel values, so that's width. And it has a domain. So the domain is just 0 to, let's pick a value, 25. All good. And then y is just the same thing, but instead of it being based on the data value, we want it to be based on the index. So the second argument you get is the index, which is helpful. So if we scale it based on that, and then our y scale is d3.scale.linear.range. So the range is between 0 and height this time, and the domain is just between 0 and the data length. So all good. And the final one we need to do is height. And again, height's a constant, and someone's helpfully already calculated above for us. So there we go. Fingers crossed. Woohoo. It's not going to win any awards for kind of looking good, but it is a bar chart. Obviously, before we throw that to business, though, we need to tart it up a little bit. So d3.scale.category 10. And then if we just set the fill color based on that. So we'll set the fill color. We're using a different kind of axis this time. Don't worry too much. I'm just showing off. Fill color I. There we go. So yeah, so you can create, that's how you use data join to kind of build a simple chart in D3. So once you've built something in D3 and you've got your head around data join, the next thing you hit across is, I want to go from having this huge long string of D3. I want to try and like split it up, segregate it, make it reusable. So I want to make components. And in D3, components are just functions, same as JavaScript. So here are two components, or here's two functions. So this is one way you could structure your D3. You could just move the code around so that you have different functions which operate on selections. That's one way of doing it. But you kind of end up with this like ugly syntax at the bottom, which doesn't look very D3. So hopefully D3 allows you to kind of invoke it like this. And you get that kind of nice chain syntax. And it also explains why you're not allowed to return anything, because the return value would just disappear. Now, this is the last Java terminology I'll use in this. I know I'm aware of the session that's coming later where we're just bitching on OO, so I'll stop. But that's the best word I can think of to describe it. Components, you don't have singleton components. You basically ask a factory method to give you an instance of a component. And again, that's all just done with pure JavaScript. There's nothing fancy about that. It's just JavaScript. And then if you've got an instance rather than a singleton, then that's cool, because you can now configure it and make it useful for your particular use case and make it kind of reusable for other use cases. So in this case, like the quote is now pulled out, so it doesn't just say the same thing every time. The quote is now configurable. So we store it as a local variable within the instance, or closure captured to the instance. And then this is how the user can invoke a function. That's like the getter setter syntax for D3. And that's how you would use it. And I've got a sore throat, so excuse me. So, components. The best way I can think of to describe them is they're just a convention-based unit of reuse. There's nothing special to them. They don't use a complex like class hierarchy or anything like that, or anything built into D3. They are just JavaScript. Another demo, last demo. Last one went well, hopefully this one will. We've got our bar chart that we built before, and I'm going to turn it into a component. So to turn it into a component, I'm going to grab the business parts of it. So the data join, I'm going to yoink it. Helpfully, someone's already put the boilerplate for a component up here. So if I dump that in, fix all the alignment, there we go. We've now got references to things that don't exist for us. So height here. To make it more reusable, let's just pull the bar height out. Let's make the bar height some configuration of the instance. So bar height. Let's give it a default value. That's kind of a common thing in D3. You want to give components default values so you can kind of use them out of the box. And then we need to bring that one down here. And then the other thing is the X scale and Y scale. So again, if we just X scale, default value of the most basic scale, we can give D3. And Y scale of the same thing. So an identity scale is like a pass-through scale. So then we need to be able to kind of configure it. So we need that kind of property syntax, and I don't propose to take that out in front of you. So if we copy it from down here, and if we stick it in the right place, then we're good. So we've got our component now. We've got everything in our component. We just need to use our component. So we just need to create a bar series. So bar, getting ahead of myself. var bar equals bar series. We need to configure it with an X scale, and a Y scale, and a bar height. Okay, so now we have an instance of our component configured. Great. The final thing we need is to invoke our component. So we have a container. We now set the data on the datum on the container. So that's basically just a way of passing via the selection the data associated with something. And then we can do .call our component. Our component is called bar. And this is going to be the most uninspirational demo in the world, because if it works, there'll be no difference. I suppose to revisit a point I said before, it is a live thing. So someone shout a number between like 1 and 25. 25. Good call. Hey. So it's running all the time. That's because it's in a render loop. There's no kind of magic binding going on. It's just running all the time. It was completely killing my computer before. So, but yeah, don't do that for real. That's not how people do D3. They don't put it in a render loop like that. That's just for the sake of this example. So yeah, hopefully now you can all go away and create components. And I've sped you through what was probably like 3 months of learning for me. I got that learning building a library called D3FC. So D3FC is kind of our solution to a problem we were having where we build financial trading applications. I work for ScottLogic, or I build them for ScottLogic. And as part of that, we commonly show charts, and those charts are streaming values like stock quotes, that kind of stuff. And we kept having the requirement, we need a chart, we need it yesterday, and it needs to have all this functionality. And we always knew that like kind of off-the-shelf products like high charts, they give you a lot out the box, they give you the 90%, but then that last 10% to kind of configure it and get it really how you want it is where it gets really painful with them. However, it was damn near impossible to argue that with anyone from business because they would look at it and they were like, well, it's fully featured and you want to start from scratch? Like, that's not happening. So our idea was to basically give ourselves a bit of an accelerator. We had a look around other D3 charting libraries, and they're all really good, but they tend to like wrap up D3, so you just get you get the kind of API you would get from any standard charting library. You don't get the power of D3 anymore. So we were trying to kind of let D3, I don't know, out. So D3FC is a toolkit for rapidly developing bespoke charts. It embraces D3. It doesn't try and hide it. So you've basically got to know D3 to use it. It's not like you can just give it a JSON input and away it renders a chart. We try to keep each component small and composable. We kind of eliminate complexity by mixing together components. And it prioritizes simplicity kind of over performance. It is, I suppose, when we first started, we thought we could build the charting library. As I assume everyone who builds a charting library, that's what they set out to do. And we acknowledge we can't do that. So what we're kind of now treating it as is just a curated and consistent set of examples of how to use D3. If you're building charts with D3, hopefully there's something in there you can either use as is, or you can kind of copy and paste and hack around for yourself. The Wi-Fi works. This is our website. You can't be an open source project these days without a flashy website. And you can see on it, we've got lots of charts and stuff. Where is it? There you go. There's your chart. Which is weirdly something you don't get with D3. D3 doesn't give you anything to render a chart. So if you want to position axes, that's up to you. So yeah, you can nab that one, just that component if that's what you're interested in. Okay. So I've given this talk a few times, and at this point I normally talk about kind of our experience in terms of like 8 hard and fast rules that you definitely should follow. And well, on one hand, I'm a bit bored of talking about those 8 rules. On the other hand, actually those rules that were like really hard and fast, like live and die by these rules and other cliches, they're not actually that hard and fast rules. As like the more we've gone on, we've realized actually there's corner cases and there's kind of nuances to it. So I kind of don't want to propagate that anymore. So instead of introducing rule 1, I'm not going to do that. Instead, I'm just going to chat to you about something that kind of came to me the other day. So yeah, React ripped off D3. I've recently been learning kind of React, and it's like I recognize quite a lot of these concepts. Like these are in D3. So I know kind of no one's believing me at this point, but I will convince you. So idempotent DOM operations is one thing often touted by React as being cool. You can re-render the same React thing into the same DOM container. You'll get the same result. That's great. It's really functional, cushy. Normally looks like this. Yep, so we could put that in a render loop, call it many, many, many times. The element identified by example would just still contain that content. Great. I've just showed you how to do that in D3. Like, D3 can do that. D3's been doing it for 5 years. React has kind of component trees, which are built around properties. There you go. So this is the React component. I assume people are kind of vaguely familiar with React. This syntax kind of blew my mind the first time I saw it. You can kind of put JavaScript in with HTML, and it converts the HTML into, it transpiles it into JavaScript. Just roll with it. You don't want to be using React without it. It's kind of the flip side of it. So this takes, this renders at the bottom. So it renders the component that's defined at the top. The component at the top takes the property that you've passed into it. It renders that as a text string, and then it propagates it through to a subcomponent. Great. D3 does that. Well, you can do that with D3. I've adopted some ES6 syntax because I couldn't fit it on the slide, but D3 can do it. It's twice the age of React. It's allowed to be a little bit more of a boast. That's cool. That's fine. So see, a few of you have convinced now. There's a few of you still wavering. So I kind of put the research in, and yeah, I went and looked on GitHub, and actually, if you look really closely, you can see that it's actually just forked from D3. Solid proof. So if I don't genuinely believe this, by the way, but if you kind of run with it, and I suppose it's the cool thing of learning different paradigms, different frameworks, that if you spot that there are familiar patterns, then kind of thinking about the other framework and thinking, well, what else does it do, and does anything else it does help solve a problem that I might be having in like the other framework? So D3, it's very easy to kind of create a simple example with it, but then over time it kind of becomes a bit complex in terms of how you deal with events and stuff like that. You can't have heard of React without hearing about Flux, and Flux has that idea as well. So Flux is kind of like the eventing model or the new MV star pattern that goes along with React, and it's basically just the idea that there's a one-way flow of information. Actions get kind of globally propagated to dispatchers. Sorry, actions go to dispatchers. Dispatchers globally propagated to all stores. Stores react, they mutate state if they're interested, and then they punt it out to the view. The view never manipulates its own state. It always kicks it back around via the dispatcher. That's kind of a pattern that we'd been half following with D3FC ourselves. So you don't try and manipulate your own state. You just let it go kind of back to the top level and then push everything through again, re-render everything. We use it in kind of our low barrel example. So we can quickly demo that. So this is the low barrel example on the website. If you've looked at the finance chart before, it should be familiar. You've got a chart at the top, you can pan it. You've got a volume chart. Kind of got these crosshairs which follow across and show the values. In fact, if I make it a bit bigger, it's probably better. Yeah, it works even when scaled. Brilliant. And then so yeah, you can pan and zoom. You can kind of see this navigator chart at the bottom shows the full range of data that you can see, and allows you to kind of gives you a bit of context where you are. The thing to notice is the navigator chart itself in the background doesn't change. It's literally just kind of the brush that moves over the top that's changing. Oops, where am I off to? So that chart uses that model of every change, throw it to the top level. Top level reacts to it by just re-render the whole chart. That's cool, but in Chrome it works. But we do have some kind of performance problems. So I want to hit 60 frames a second. That's what I'm aiming for. That's what all web devs are aiming for. 60 frames a second, so you can see whether you're getting it or not, kind of visually, or you can dig into the developer tools. This is a snapshot from the timeline view in the Chrome developer tools. It basically is showing you a graph of the call stack over time, or like the inverted call stack over time. And yeah, so that's going left to right and down. And at the top is a number which kind of tells you how long you spent rendering a frame. So if you've got very good eyesight, you can see I spent 27.7 milliseconds rendering a frame. That's a lot more than the 60 milliseconds you're allowed to get 60 frames a second. So Chrome has helpfully given me a naughty boy warning triangle. So of all of the time that we're spending rendering this frame, we're spending kind of where that arrow's pointing, rendering the navigator chart. So the navigator chart, bear in mind, the only thing we're changing is that brush that goes over it. That's the amount of time we're spending rendering the brush. That whole rest of it is kind of useless work that we're doing. So like, there must be a way to get better than what we're doing. So we've already adopted the kind of the React kind of Flux. If you know Flux, I apologize, I'm bastardizing its definition of it. But it's, yeah, we've kind of already got that. So is there anything else we could do? Like, we don't want to start implementing caches kind of in the traditional MVC way. You would kind of try and get a direct reference to it, but then you're going to end up with like event handlers all over the shop, and you're going to have lots of crossing dependencies. Things are going to get complicated. And that's the idea of Flux. You kind of eliminate that complexity. So what could we do? And the solution that I've been thinking about and playing with a little bit is another thing that's popular. If you look at React and Flux, is then immutable.js. So immutable.js is a load of immutable collections that you can use just in JavaScript. And with immutable collections, you get the ability to dirty check really, really quickly, because a dirty check is basically just saying, is this thing the same instance as this other thing? So if we had that, and then we brought in kind of immutable components, then every single component can cache its state internally and know that as long as it dirty checks the incoming data, because it is a pure representation of that data, it can just spit out the existing data. It can go really fast. If anything changes about the object, that would invalidate the cache. That's not caught by the dirty check. It would cause you to get a new instance of the component. So if your components are kind of immutable and your data is immutable, and therefore you can dirty check it very quickly, you can theoretically speed it up quite a bit. So that's the good news. The bad news is this thought only occurred to me the other day, so I haven't kind of done anything useful with it. But hopefully, or if you want to kind of play with it, then I'm going to be playing with it over the next few days and weeks. So yeah, join in. That's kind of where I would like to see kind of chasing down the performance of components and kind of the component pattern in D3, and where the kind of React and Flux and immutable.js can kind of cross-pollinate the ideas. So yeah, in summary, React didn't rip off D3, probably. So yeah, that was creating D3 components.